Right. Yeah.
We're not allowed to say that anymore.
Here with Joe, Shearer, Eric Mele. We've done this last year. Did we skip?
Yes.
Did we do it last year? I don't remember.
Not last year,
but this is one of the weirdest things that we do at the symposium, but I'll enjoy doing it, which is we just have a conversation about whatever technical topics, life topics. It's just an ask me anything.
Yeah.
So good to have you guys again.
Great
And
to
our
be
audience as well.
Yeah.
So we actually have a group here for once. It took a lot of work to even get, a handful of people back in this weird room. So, but no, there's actually been a lot of good conversations going on here.
Yeah.
What was that?
I was about to say, what did you have to do to coerce them back here?
There was promises of free tools and candy, ice cream, extra raffle tickets. Yeah, for sure.
Was that you in the white van earlier?
What? My kids call it a kidnapper van.
Yeah.
Yeah.
Offering the free candy.
Candy, kids. All right. So the first question. So sorry, what was your name? Terry McWilliams asked. Well, I just gave your whole name on the internet. Jeez. All right. So hopefully you're not like in the witness protection program or something. So, and everybody who's on the live stream as well, feel free to just add in questions or anything you think we should talk about here. His first question was, it wasn't about getting new technicians. It was about how do you get them? How do you introduce them to some of this more advanced stuff, like the building performance and all that? So do you work in residential then, I'm imagining?
Yeah, residential,
like commercial residential. Okay, cool. So I guess like, how did you first get interested in more like advanced stuff? I know you're not really like a building sciencey guy, but you still like you pinch off discharge lines on compressors to test them and stuff like that. That's a real throwback. It's a throwback joke that nobody gets.
Yeah, you can pinch off the suction line if you'd rather that too. But we don't need to get down there again. But yeah, I think it's very personality driven. Like I'm definitely someone who kind of questions things and I want to know the why, which probably really aggravated my parents, like taking things apart and just trying to almost be like a mad scientist with things is just kind of my personal attributes. So I do think it's somewhat going to be varying from person to person, whether you're young tech really is like passionate about learning and absorbing as much as a sponge, or someone that's just like, I'm here to, do this job. And as far, and you're probably not going to make everybody be someone who's super hungry. And it's not that they're invaluable at that point if they are just here to do a job, because it took me, I didn't just, show up day one and was like, oh, I love this. It was like, honestly, I was like, air conditioning is terrible. I mean, you're up in the hot attic covered in insulation. It takes a while. And then once you finally start to kind of know the basics, then maybe you could actually develop that passion. I think it'd be really hard to develop that passion
right off the bat.
Yeah. Do you think?
Well, I think that different people are motivated by different things. So my answer is like, you have to know something about that individual and what they're motivated by, which is where I suggest most people start when they're hiring. But even with your current team, like if you don't know about like what really interests and inspires the people who work with you, then you're going to have a hard time getting them interested in something, and that's actually, so even fundamentally in the language we use, and I do the same thing. I think we all do it, where we're like, how do I get so-and-so to do X, Y, Z, right? You don't really get people to do things. People are people, and they're on par with you in every way. So either they're aligned or they're not. And so you have to actually adjust your alignment with them. Or you can often support them with something that kind of accelerates who they already are. So exposure is big. I think a lot of people, the thing I've come to realize is people really tend to like things that they're good at or that they feel like they could be good at. And they tend to not like things that they don't feel like they can be good at. So why you don't ask me to play like board games or like chess, because I stink at it. And it's just, if I was good at it, I'd probably love it. Bert keeps challenging me. Are you a chess player?
No.
He has a chessboard out here. He's playing chess with people. I don't know. It's weird. Apparently he's good at chess? I guess he puts a lot of time into it, probably when he should be working.
Yeah. Maybe should put some of that time into HVAC.
But that's okay. I digress. But yeah, so I guess my encouragement would be like, think about what got you here. And then don't just say, hey, well, they have to be like me. It's always a progression. And there's always these sort of moments of inspiration, but usually it's around solving a problem. Most of us are problem solvers. We like puzzles, puzzles to solve. And when you find a puzzle that you can't solve, and then you're like, aha, and then you fall down this rabbit hole. For me, it was back in the early 2000s, we had a bunch of hurricanes. We had all these mold issues that I was flailing trying to figure out. And then once I learned about a lot of these technologies, and I learned a lot more about the envelope and building performance and all that, that really kind of changed my perspective. What about you, Eric?
Well, I don't have any employees, and I don't feel I have much to add to.
Yes, you do. Because yourself, like what got you kind of falling down the rabbit hole of different, really actually
I guess
understanding
just
things.
the interest, my native interest in just how things work and figuring out things like you guys were mentioning of like, you start to see some of the puzzle pieces and you're like, well, how does this actually work? It's
Right.
like, when you first start as a helper, you're just fetching tools and doing the really simple tasks. And then you see the more complicated tasks, like, how does the refrigeration cycle work? How does wiring schematics work and the controls and everything? And start to like take it upon yourself to be interested in learning that. Because if you're not interested in learning that at that point in time, it's, at least for me, it's really hard to try to actually force that knowledge in and retain it.
Yeah, that's a good perspective. All right, we got some technical questions coming in online.
All right.
Did you have anything else you wanted to say there? You look like you had something else there.
We can go to the technical stuff.
Yeah, let's go to some technical stuff. We're kind of this is kind of a technical group here. All right. So from John White, he says, does a variable inverter system, indoor and outdoor fans, mitigate any issues with excessive supply ducts and then needing to close partially or fully some of them?
Okay.
So I think what he's saying is, because then he also is asking about iris dampers worth the cost versus plain mechanical dampers at branch trunk interface. And then he said iris, not Irish, LOL. Irish dampers, I think, would be something else altogether.
So is he trying? If
I think he's saying like, yeah.
Are you saying? Let me ask this:
Yeah.
Are you saying that will variable speed indoor fan? Because we'll just say that you're talking about ductworks.
So
Can
he's clearly asking a question about an actual,
Yeah,
that type of I guess that is what you call it,
an iris?
Is
I
that
guess
what,
that's okay. Let's say.
what are you thinking? What are you thinking?
I think he's trying to use the equipment to mitigate an airflow problem, which
Mhm.
it's not going to work.
Yeah.
You cannot use a system to mitigate a ductwork issue. You need to address each piece of the equipment individually and let it come together as the building envelope.
Yeah.
You can't use one to fix the other. It's not going to be as successful.
Yeah, but because he's asking about iris dampers, that's a little more advanced.
Yeah,
So I think maybe what he's saying is can you work together with that type of damper in order to mitigate issues? I don't know. Or you can just change the subject too if you want. That's the other thing. We do like politicians and just answer a question he's not asking.
He was talking about a fully variable system though. So if the ductwork can't change when the fan speed,
Got it.
And that could make it
all the air
worse.
is going to take the easiest path, which is usually going to be like the straightest run.
Okay.
And in low stage, it could be bad.
Dampers,
Along with that does seem to be what he's saying. And actually, this is something I have thought about. Is this idea of actually modulating your ductwork at the same time as your equipment in order to maintain face velocity. But the problem with what he's saying is that has to be at the actual diffuser, at the actual whatever vent, diffuser, grill, whatever you want to call it. But no, I like at the actual output, because that's the only place that velocity matters for the sake of throw.
Okay. Wow.
You can do it earlier in the duct. If the outlet stays the same size, it doesn't matter what you do down line. You're still going to have low velocity.
Oh, so that was more of a
Well, that's the question we're going to answer.
That was a deep question.
Let's talk
Deeper
about
than
this.
it-
Let's talk about this anyway, though, because even if that's not what he's asking, I think it's an interesting question. So if
Yeah.
you reduce airflow and you
Yeah.
keep your vents
Yeah.
the same size,
So
then you're not going to get good throw and as good of mixing.
it's true. Yeah. And so it does kind of heal itself in the way that if you start to, well, it can or can't heal itself, just depending on like where your thermostat's located in that scenario. Because if the system is, let's say you had a far run master bedroom that was always warm before, now you sell them a variable speed system. So in low stage is now getting even less, and the thermostat's across the house, then yeah, you could have a real issue there. I don't think any sort of face velocity damper would fix a problem like that.
Well, and I guess there's two different things. There's two different things that they're talking about here. So one is, I think what one challenge is especially in larger duct systems, as you reduce pressure, I think he's saying you're not feeding equally. That's one question. But then there's the face velocity question, which is a whole different thing, and that's something I don't think a lot of people think about, which is that whole. A lot of people are very concerned about, oh, I don't want my ducts to be oversized. And that's what Ed talks about and Alex and all those guys. You can't oversize ducts. You can have an oversized outlet and an oversized vent, right? Because then that results in poor face velocity, which then you don't get that entrainment and you don't get that mixing. So I think there's two different possible questions here. The first one, I think you don't solve a problem with distribution because you're relying kind of on a pressurized system in the first place. If you're having that issue where it's all dumping at the closest vents, like that seems like a whole different problem to me. Like a duct design problem.
Yeah.
But maybe that's what he's saying is maybe you're compensating for a duct design problem there.
Yeah.
I'm rambling a lot. So what are you hearing here?
No, I mean, I agree. I think you do have to be, careful about what kind of duct systems you will put a full variable speed system on. Because there are definitely issues if you don't zone it on a big house. You like you said, you would almost want to design it for in my opinion, personally, you'd almost want to design it for somewhere like the intermediate airflows. Don't size it for the full stage capacity. Make it be maybe a little bit, higher in the static ranges at that point, because it's going to live there for very little of its life. Fully variable speed system, you could probably look at some data and see it's in high stage very little.
I feel self-conscious because Sophie's sitting here and she actually designs duct systems. So I'm not bringing you in on it. I'm just saying I get because this is like Reagan talks a lot about this and on the zoning side, NCI talks about it a lot too. And that's not my expertise, but I guess where I would kind of end this question, because we're going to talk in circles, where I would end this question is don't get confused about face velocity and mixing in a room. Don't confuse that with challenges that you face because you have a really poorly designed duct system where you're relying on pressurization in order to get air places, right? That's not really a great system anyway, if you're relying on that, I guess. And so fundamentally, if you can solve that problem, solve that problem. And zoning can help in some cases, but using it as a Band-Aid, I guess the question always is, are you designing a new system? Or are you trying to fix an existing problem that a client has? And I think that's one of the questions he's asking. Is that Iris design better than a typical butterfly damper? Well, the answer is yes. I mean, butterfly dampers are kind of junk, but they are what we have and they're inexpensive. So that becomes a cost benefit sort of thing. So,
and I would say even with the best design duct systems, you would still want butterfly dampers.
Well, and there you go. That's the thing. In retrofit applications where you're going and fixing a problem, a lot of people are like, well, you're using manual D. I'm like, no, if I'm fixing a problem, I put in a big duct and I put in a bouncing damper. That's all I do. Right. And then put in dampers everywhere else. So all you're trying to do is not increase your system static so that it affects the equipment. And then ultimately get more air to that zone. That's a realistic approach.
In the real world, there's a realistic thing to using fan horsepower to solve problems.
Oh, right. Commercially, you do it all the time.
And so why can't we do it in residential?
Well, because it just ain't right, Joe. It just ain't right.
They just made this 15 SEER a 14.5.
Well, I mean, it is that. But also nothing in the system is engineered for it. I mean, so a lot of times you run into your coils aren't designed for it. And so you get if you're trying to, even the cabinet, so you get air sucking in from all the different areas and you get water blow off issues. I mean, when you have high static pressure on these systems, the motors aren't designed.
High return static pressure on a traditional air handler. Supply static wouldn't cause any of those things.
You're right. Yeah. But either way, were we only talking about supply?
That's where my head was.
Okay.
Thinking with
because that is what he was asking. Yeah. Okay.
So,
That's a good
I use
distinction.
fan, and that's like in a retrofit application, you might look at a fan chart for some units you're going to use and think, oh man, this X13 motor's got a really weak program in it. So,
You got to chip it then. It's just like a diesel truck.
Yeah.
You just tune that bad point.
You
Yeah.
put like 400 volts to it. And
Okay. Here's a here's a question. Here's a question for you. Have you ever replaced an OEM PSC motor with an ECM, aftermarket ECM, in order to try to solve the problem?
Yes, I could do this. I could solve the problem with another PSC.
I'm just asking
motor.
if you have done it. Like, have you
I would
actually
say,
done it?
Yeah. Well, I wouldn't say I have taken out a perfectly working motor, put in a stronger one to solve things. But let's say I had some history with the system and the motor was failing, and it's like, well, this system always struggled a little bit on the airflow, so maybe we'll go
right
a little more horsepower on the, which again may have zero impact, because if the motor is kind of unloaded anyway, the old motor was spinning at its top speed,
right,
synchronous speed for
right.
a PSC motor,
right.
Just putting a bigger one in really isn't gonna.
Talk about that, because I think a lot of people don't understand that. Talk about that, like what you just said there.
Yeah, so a fan motor, let's say it's a 3rd horsepower, and the door nameplate rating says 2.9 full load amps, and you measure it, and man, this thing is only doing like 1.3, and you can almost usually use your ears to tell that this air handlers have a different sound when those motors are kind of hitting their synchronous speed, which a regular PSC motor running at 240 volts is only going to spin so fast. It's
based on the poles.
Yes.
Right. So the synchronous speed of a typical 6-pole motor is 1200 RPM.
Yeah.
Yeah.
A lot of will say 1075, but some will say.
But that's with slip factored in.
Yeah, exactly. So that's why you might see, some people may wonder that too, is I've got an 1125 RPM motor.
Right. Can I replace it?
How am
with
I going to find
1075?
that? It's like,
right.
There's nothing different. They've just, kind of decided that.
Right.
That's what the name.
The engineers are like, our motor's just a little more slippy.
Mm-hmm. Yeah.
Just a little more slippy.
So
the point, okay. So
the point is that motor is unloaded. It's spinning at its synchronous speed. It's spinning that blower wheel just as fast as humanly possible on the voltage you have at the house.
Well, yeah, but here's where what you're saying is an incomplete story, because I have done this before years ago, before I even started Kalos. A 1070, so a 6-pole motor at 1200 RPM, fully unloaded. So what you're saying is, because the static pressure is high, this is what a lot of people miss, and this is what I wanted to. We said it like a billion times, but an old PSC, permanent split capacitor motor, when you have high static pressure, it's going to spin faster. And that's what blows everyone's mind. Because like, what do you mean it's under more load? Well, no, it actually isn't. Load is the amount of pounds of air you're moving, right? So if you're moving less pounds of air because you have higher static pressure, then, and again, that air is also less dense because of that. You're going to, well, on the return side at least. Yeah, return side, yeah. You're going to run your synchronous speed. You're going to run up, but with an ECM isn't bound to that 6-pole number. An ECM can
1400 on ECM.
Oh, I actually don't know the answer to this.
Number.
It's bound by a number, but it's not bound by 1200 RPM, and so it will spin faster than the maximum synchronous speed of a PSC motor. Yeah. And that's the fundamental thing that an ECM can do to overcome airflow problems. To your point, it's not like that's not the solution, right? But sometimes you're stuck in a situation where it's like, this is like, I can't replace all the ductwork. Maybe it's in between floors or something. And so you're trying to get some more air out of it. You put an ECM in, it's going to actually ramp up to a degree that you wouldn't have had. And that's why an ECM draws more current at high static pressure.
And the current is like to the 7th power.
Yeah, no,
right. Start to,
right. It is right. It's like an exponential. Yeah.
Increase. Like, and if any, just do a little test next time you guys have a true variable speed motor where you can set the dip switches. Just start pushing it like 100 more, and you'll see like, wow, 100 more took like 2 amps more. It went from 2 to 4, doubled my amperage, and so you can see how much it increases. And something else to the subject about making that blower spin even faster than synchronous speed, is that's when you start to see blower wheels come apart.
Right. Well, right. And that's where,
Mhm.
like, I remember when it first came out in Train, we did a lot of Train at Delaware when I was there. You were having blower wheels flying apart all the time because they didn't have programmed limits set into them. So they would these things would just like ramp to the moon. You probably had a lot of that too, right? Well, nobody can hear you right now because your microphone's getting, there you go.
Everybody wanted to set it to the highest airflow. That's what some people would say. Just like put them all up,
Yeah.
the way.
Yeah.
Doesn't matter if it's a
More
5
airflow is better, right? Yeah.
5-ton air handler, 3-ton unit, max airflow.
Yeah.
Or they're just factory
2,500
shipped
CFMs.
that way, so.
Yeah. And I did that a lot early on before I understood the impact on humidity. Like, you know, I just thought, well, it's variable speed. That means it's good on humidity. Jack the airflow up, right? I didn't, obviously, that's super dumb, but I did that several times. I wish I knew where those houses were so I could go back and reset their dip switches. Why do I keep replacing blower wheels? This is so weird. Yeah. All right. What is your take on A2Ls?
I don't know. I mean, yeah.
I ask you this because you always have a very pragmatic, like you don't buy the marketing, like you're meaning like you're gonna have your own take on it.
Yeah, so my own take personally is more complexity with these leak sensors they're talking about. More cost of equipment. Am I personally scared of the flammability? Not when I've heard so many great webinars by Bryan and his guests that like you can't get the flame to carry hardly at all. Now, I would take it more seriously about having compressor terminals vent, because as it is now, we have zero flammability refrigerants, and when it's like aerated with the mixture of oil and heat, you can have pretty violent terminal blowout. So I would expect those to be maybe take those a little more seriously with the A2Ls.
Yeah.
The glide seems to be, as of yet, not a huge issue.
No.
Correct.
Right. Yeah,
so
glide's not an
that's
issue.
good. That makes my heart happy. R32 kind of makes my heart happy just because I love R22.
And it's really close in number.
Yeah.
Yeah. It just makes you
And
feel
it's a single,
yeah.
it's a single component refrigerant. So that's nice. But we're gonna have to. And I went through the R22 to 410A transition, which was probably a lot harder for people, right? Because we had never really had such an industry, like we had never had a hard date where like things are going to stop and change.
Right.
And I mean, they were telling us we have to have separate gauges.
Oh yeah.
We have to run a line set on every single job. If the two oils meet, it's going to create this like nasty stuff that's going to destroy the equipment within days.
Right.
We thought,
Well, and I think honestly, the reason why we thought that is because of moisture. Like, so we were seeing that happening, but it was actually because there was moisture in the system that they were then exposing.
Moisture doesn't even really seem to bother 410A. I mean, not in any
the POE. That was
POE,
the transition.
It doesn't really seem.
Oh, come on, Joe. They absolutely does.
I'm gonna have to. Maybe we're gonna have a disagreement.
I'll give you. No, we're not gonna have a disagreement. We're gonna have a fight because, like, when we first started, when 410A came out, I was the training manager at Delaware at that time. Like, so I was doing all the training, and we started putting 410A systems in, and we were terminal venting black sludge within a matter of days. Now, when you say moisture, like I think we there was times when they were pushing line sets through chases uncapped. So it's a different level of water content probably.
Yeah.
But we did not have that issue. Like we went from
you can't
not
say
having an issue.
R22 is fine with that. You can't.
It is.
That.
He was happy. R22 is like, man,
that's a
I've been
little-
doing this for 30 years.
I'm so hydrated.
No, literally, if you go up and ask an R22 tank, he's like, I've been doing this for 30 years and I never had a problem.
I can take a little water in my life.
Yeah, you go over to 410A and he's like, well, actually, it's got to be 72 degrees.
Perrier water?
It is right. Yeah, R410 is like, I only drink Perrier.
I can't take Chase.
I'm not
Sunset
okay with
water,
this.
Rainwater.
Yeah.
Ugh.
All right. Where's the first aid kit? I don't know. I'm gonna need to speak to the safety manager. That's how 410A sounds.
That's how they made 410A sound like.
I'm not making fun of anybody. Okay. Sorry.
Techs were afraid of it blowing up in their trucks.
Right.
When 410 first came out.
Right. Oh yeah, right.
Higher
You talk
pressure.
about
Yeah.
yeah. No, and I was one of those guys. I was
Yeah,
definitely in
one of
that.
those guys.
All right, I'm gonna yeah, I'm gonna turn it over to Eric. Eric, any thoughts on A2Ls?
It's just another thing we're going to have to deal with. Unfortunately, we don't get to pick the fluid that goes in the system. So, I mean, I really got no opinion. I'd wish they would go to something with a lower pressure.
What does your
Yes.
daughter think about it?
What do you think about A2Ls?
No.
No.
She says no. That's the final word.
You got my vote.
Final word. No,
Yeah.
absolutely not. Sorry, Kimura, you're gonna have to rework everything. My bad.
I think lower pressure would be nice because it just seems that the leak rate has gone up when we started using higher pressure gases from what we had before.
Yeah.
So I don't think we're really gaining anything even environmentally because it's like, okay, it's slightly better for the environment, but we leak way more of it. So
and that's always been my biggest. Can I say beef? Is that okay? Biggest beef with the industry
This completely.
is like, how about we focus at staying on the system inside the system in the first place,
Yeah.
and where are the consequences to manufacturers for
Right.
their leak rates that are caused by their manufacturing. That's something that, and I'm not blaming them fully. I mean, I think it's everybody has to have a stake in it, and that's a little frustrating to me. But
I think it's the efficiency standards has made them thinner wall, rifled tubing
Right.
with thin walls, like to chase these efficiency numbers.
And fitting in the same footprint.
So it's the only way
it's
to
a
really do
recipe
it.
for air. And I personally don't have a huge belief that the pressure would really drive leaks. I feel like, 300
Well-
pounds versus 500 pounds. I don't know that it's really going to like.
So I'll disagree in the case of formic corrosion. So formic corrosion is this ant nest corrosion, which is the vast majority of what you see when you actually look at it. And so if you imagine there are these tiny little cracks, and now you apply more pressure to already existing leaks, now you create a much larger
Okay,
leak. So in non-leaking tubing, I would agree. The tubing should not be the issue, should not be the weak point. A side note is that I really question manufacturing practices, because I've actually pulled apart some coils sometimes and actually found the leaks, and it didn't look like formic to me. It looked like manufacturing issues. And when you see have you guys ever seen how they put the fins on tubing?
Oh, yeah.
It's pretty cool.
Mhm.
Yeah, they shoot that pig through, and it expands it, right? Well, think about if there's any imperfection in that pig, or there's any contaminants in the air or whatever that make it inside that tube. That's a pretty violent process. I think that there's some things that I've looked at that make me think that might be part of it. And you think the manufacturer's going to be like, yep, we made a mistake in the way we manufacture the product. I don't know. I mean, I'm not pointing fingers or blaming, but I am asking that question of, are we really making sure we're controlling that as well as we could? I did want to ask another question, because I think the questions that we've been asking about A2Ls are all about like the equipment sensors, the mitigation and the equipment, terminal venting, all that. My bigger concern is leakage inside the structure from the line set, which is going to be really it doesn't happen very often. So I think that's why I haven't been thinking about it. But imagine you have a line set that's running through a and one of the questions here was like, well, you can't penetrate roofs, you can't penetrate walls. A lot of that stuff's still in flux. Like there's still a lot of because you have different bodies that regulate these different things. So you have ASHRAE and AHRI on one side, on the AC and refrigeration side, but then you have like the National Electrical Code, and what's the NFPA, right? Who actually sets those standards, and then you have local municipalities, local authorities having jurisdiction, AHJs, and so you're getting a lot of different messages. And that was a question that I asked a panel at AHR, and they said they are trying to work to standardize it, but a lot of that stuff isn't standard yet. But imagine you're running a line set through a closet. Sorry, I'm waxing too much here. Wax on, wax off. It's running through a small closet, and you've got a 5-ton unit, and it leaks in that closet, and the volume is such that if it all leaks out in that space, that you go above the lower flammability limit inside of a structure. That worries me. Right? I don't really care. Terminal venting outside, I'm not really worried about that much. That doesn't, because they even say like, you don't know what.
You're not worried about. I mean, for a technician, that will be the more dangerous part of working with A2Ls.
Well, yeah,
The
but
most
I
dangerous
just
part.
don't think that because if you look at the flammability of A2Ls in comparison to A1s, we've already seen ignition events with oil and terminal venting, right? You've already seen terminals blow out and you get the flame and all that, right? That's not new to us.
No, but I mean, what's new to it might be like, don't you think it's gonna be 10 times more violent?
No, it's not. Like they've actually
Okay.
shown what it's like they've done the ESCO and Chemours have actually shown what it looks like between an A1 and an A2L, and it's not like
Mm-hmm.
right. Propane, right?
Yeah.
So those of us who have done propane,
Mm-hmm.
because that exists in refrigeration, R290 exists in refrigeration, and techs keep thinking that's
Mhm.
the same thing, and it's not. It's much more. A2Ls are much more like A1s, what we've been working with, than they are like propane. But if you fill up a room with an A2L and then you have an ignition event, now you've actually got to me, that seems like a bigger problem inside someone's house.
Just the way my brain works, and I'm no scientist on this, but like if it's not any more violent when you have heat, compression, aeration, and ignition from a compressor terminal venting, then you ain't gonna have to worry about it like combusting in a room.
You'd have to have an open flame.
And
Present.
even then,
It seems like an outlier event, but imagine, say you have
and we have like,
you have a VRF system that's
Yeah.
got like on a big custom home, and it's got like a significant
Mhm.
amount of refrigerant charge in it. And they say, no, it's okay because the equipment has mitigation in it, but you're running a line set through this enclosed area, and it's filling up that space above the lower flammability limit. That to me still seems like a bigger concern. Obviously, like only because they've already thought about it on the equipment side. Right, they've already made changes on the equipment side to reduce those risks.
I've always wondered though if this sensors mitigation issues are going to be like the 410A, where it's like 5 years they're gone. It's like it's not really,
Because they realize it's not a real issue.
Yeah, I just personally, I kind of feel
fire
like
is kind of different.
You think?
Yeah.
Yeah. But from what I've heard, like you cannot get this stuff to burn. Like
I mean, you can with an open flame, yeah. If you expose it to, it just requires more initial ignition energy, and then when it does burn, it doesn't burn as.
And my answer to your specific question would be, we've got propane lines running through people's houses with a giant tank. And we've got natural gas lines running through people's houses with an endless fuel supply.
Right. Okay.
So we're going to worry about a little bit of
No, that's actually probably the best, because I've actually said the same thing. Right. We should have automatic shutoffs on natural gas lines first and foremost.
You would think.
Yeah. Right. And I don't know. I don't think A2Ls have any odorant though. Like I don't think they have anything in them that allows you to distinguish them.
Yeah.
Pretty sure they don't.
It's got odorant and it runs through an attic.
Yeah, but you're still going to smell it. Like
Maybe.
propane, you smell it.
Maybe.
Like you walk into a garage where there's a tiny little pinhole. That's that Bert video where he's like sniffing around the gas line. That may not be a bad idea if they can make it where it doesn't damage the equipment. But you're saying you don't think it would matter.
No, I'm not saying not to put an odor in if you couldn't, but I'm saying there could be situations where you just don't have it in a space where people are going to get the odorant. But then would it be enough to be a problem?
Right.
So,
but to your point, like that's the same thing. We're running gas lines through attics and through walls and all kind of stuff all the time.
Much more volatile, much more
unquestionably. Yeah.
So why are we like acting?
Why are we freaking out?
Yeah.
Which is
so that's goes back to my thing. Like these sensors will be gone in like 5 years because there'll never be a house and they'll do more testing and they'll find out that it's like impossible to get this stuff to actually ignite.
Yeah, maybe.
Yeah, we'll see.
Okay, good.
Yeah.
All right, that was kind of boring. Any questions you guys have? Go ahead.
Just a thought on what you asked, because it's going through the home, just like we have smoke detectors, carbon detectors and all that. I think if it does come to an issue, it's going to be something that the industry is going to be more reactive than proactive.
Yeah.
And it'll be more on the NFPA and the electrical code,
Right.
the fire codes that, hey, homes that have this new construction is going to have this sensor in the home. So that way, if it is a problem, which I'm a little bit more on his side of, I don't think it's going to be that real of an issue, but if it does become, it's going to be a reactive sensor that's going to be assigned to the home, not necessarily the equipment, I think.
Yeah, that sounds right.
Yeah, if there is a massive home explosion and
right, and that's what. Yeah, and then that'll be like, okay, now everything changes. Yeah, go ahead, sir.
Yeah, I would love. The only thing that I really see that really bothers me is manufacturers want a couple different kinds. Right now, we're having to haul R20 R22 still for some old systems.
Right.
We've got R410, then we're gonna have 2 more refrigerants, and then you start looking at recovery tanks for everything.
Right.
And the drop-ins.
Yeah.
So,
Yeah. So his, in case anybody can't hear on the live stream, his feedback was like the number of refrigerants is a big concern. Recovery tanks, having to carry it, all that. And that's what that's what I've always said. I mean, Eric works in commercial. Let me speak to that a little bit, Eric.
Back doing grocery, you had 20 tanks on your truck.
Yeah. And that's just going to get more and more probably on that side.
Now we're going to have 3 more to add to that.
You're going to be driving tractor trailers pretty soon.
You're going to be hauling.
Which would be kind of cool, honestly, but probably not great for the environment either, if that's what we're trying to save. So that's
Well,
something to think
The
about.
good news is too is that it's going to be a little while before you need that. I think it's going to be a few years after this stuff comes out to where you really need to have tanks R32 and 454 on your truck. It was that way with 410A. It was several years before you're like, oh, I ran across one of these new systems that was leaking. To really need to have it. But I'm a small shop, so that could be debunked if anyone wanted to. But
One thing that I find helpful is just to keep some extra recovery tanks in your garage. That way you don't have to keep them all on your truck. That way when you put some gas in one, you can put it in the garage and then you can consolidate them later at the shop or wherever.
When you say put it in the garage, you mean set it in the garage,
Like
not
at your
like open
house.
the valve in your garage, right? Just
Yeah.
with a hose.
yeah.
Hey, well, I get money for that stuff. I mean,
Yeah, right.
not an
No, and it is
insignificant
actually the
amount.
economic driver is kind of helpful to drive better.
Make sure to
behaviors
fill
there.
that tank to the minimum amount of pounds to turn it in so I can get more money. Put it in 4 different tanks instead of just 3.
yeah, Eric even puts water in his.
Yeah, put some water in there,
Just fill it up. Yeah. Get some
Whatever,
extra weight
whatever,
in there.
your extra-
Whatever you happen to have laying around.
When you change the oil on your car, you just put it right in there. Put a gallon in each. You'll never
Stop it.
know.
Somebody else had something. You had something you were going to ask.
I was more concerned of contractors bypassing those RDS sensors and stuff like that. Because there's a lot of technicians that like to go top and go, right?
Yeah.
And if it's having intermittent detection and cycling off that outdoor unit,
Yeah.
I think they're going to bypass them, and that's going to open up a whole realm of liability.
Yeah.
100%. If they let you bypass them.
Mhm.
Some
On a
of them,
communicating
I've
system.
seen it'll be easy to bypass them, especially when they're using just a standard relay.
Yeah.
To kill you. Yeah, but a communicating system might be a little bit tougher.
Different, yeah.
Yep.
Communicating system would be different,
Mhm.
yes.
Definitely not. Yeah. Not something that for liability reasons, even if it isn't your fault, if you've bypassed something, you're still going to get blamed. Remember that. Just remember that. That's really key.
Yeah, it's like in the quality of everything else these days, these sensors are going to be hopefully not, but probably going off when there is no leak, right? How are we going to deal with that service call?
With grouchiness
Yeah.
and
Yeah.
choice words, probably.
Yeah.
Procedures, actually leak check.
Yep.
That would be
Yeah,
that
see
would
if
be
the
ideal.
system's low, maybe.
But that's
Yeah.
actually probably one of the biggest changes to EPA regs that a lot of people aren't talking about is the fact that now there is going to be a leak rate limit in residential, and that did not exist before,
Okay.
right? You did not, because you never went over 50 pounds. And I think it's still it's like systems over 20 or 10. I don't remember the number. I should know that, but I don't. I really have a hard time staying interested reading regulations. It's kind of
Mhm.
boring, especially when they change like every
Yeah.
3 hours. But
I'll learn
that
it
is
when it's
going to be
ready.
different, because I was the one who was always saying
Mhm.
when guys are using that as a way to sell equipment. Oh, I'm sorry, ma'am, I can't add any more refrigerant to your system. It's like, that's not true.
Right.
I mean, it's fine if you don't want to do it, but don't lie. Don't make up a regulation that doesn't exist. But now that is changing as part of the new. whatever it's called,
But
AIM
it
Act,
sounds like it
whatever it
won't be super applicable.
Track the leak rate.
It's a contractor.
So I call you out on Monday and I call Joe out on Tuesday.
Now you just exposed the whole strategy to get around it. Thanks,
I'm-
Eric.
I'm just saying,
Yeah, right. No, you're right. You're right. Yeah.
so the contractor is supposed to keep records now of when they add refrigerant on a residential call.
Yes, with the new under the new standard, which begins next year.
Is this going to
That's my understanding.
retroactively apply to 410A and 22, or is it just going to be the A2Ls that are under that?
Well, no, it would definitely be. It would do. Old stuff would be worse. I mean, this is about. Right.
I'm not
No,
disagreeing
again,
there.
I'm kind of making this up as I go along. That's my understanding. Go ahead.
Are we supposed to be tracking all of our refrigerant stuff anyway, the EPA logs and stuff?
Yes, but it's a weak yes, because we're definitely supposed to log it in equipment that we decommission. So when we remove equipment from service, we are supposed to keep a log in residential. If it is under 50 pounds, then recharge does not require any sort of a log currently. Under 50 pounds, over 50 pounds, yes. And then the leak rate requirements come in. But that's where I'm saying now that is changing too. So it's going to, refrigerant logging is going to become a much bigger business on a compliance side. And again, up to this point, this is the thing that, I probably shouldn't say it out loud, but there's been zero enforcement. So there's regulations, but the only people who ever get hit are like big corporations, like grocery stores. The EPA will come against them, but regular technicians, regular contractors, that just doesn't happen. It's not. And people are talking about, oh, I'm going to turn you in. It's like, well, okay, whatever.
Yeah.
Unless it makes some enemies.
Well, of course, right? And that's the whole thing, right? There's, obviously, if you make an enemy with the EPA or a regulator or a government official, yeah, probably. But why would you do that?
Even
Why would you do that, Joe?
I wouldn't.
Yeah.
But I always tell people when they say that too, it's like, just go. As far as I know, a couple of years ago, no one has ever actually gotten that reward money,
Right, the bounty
in the history of it.
Yeah, right. That's
No one's
not-
ever actually gotten it, and no one's actually ever been charged with it, except for, I do think there was, I read a story about they charged some scrappers with that in
Right.
conjunction with all the theft charges for cutting up a bunch of rooftop units.
Right.
They
But
hit them
that's-
with that charge, but there hasn't been like a contractor who has ever actually been hit with that venting.
Yeah, but that's
Um,
akin to like shoot, who was the famous mobster who got like put away because of tax evasion? Yeah, Al Capone. It's kind of akin to that. And again, I'm not encouraging do
Do you think it's going to be worse in the future for that? There's going to be more
Enforcement?
enforcement.
that's all political. Like
Yeah.
that depends on administrations and all that stuff.
Yeah.
We don't know. Who knows?
Yeah.
I'm not. And I don't come down on either side of this stuff. I just
Mhm.
talk about what is,
Yeah.
like I'm not, I don't make political statements on HVAC school. I definitely do when I've had a few in me after dinner with my family, but that's my own business.
Had a few LaCroix in you.
Had a few extra LaCroix and that sparkling water just tickles the tummy. All right. So let's talk about, I'm just going to put you on the spot, Joe.
Oh,
Oh, no, you're looking at the
gosh.
audience. Does anybody have anything out here? Anything you're thinking about? I want to get off A2Ls because I'm sick of talking about it. Well, yeah, go ahead.
Like work-life balance, I guess, coming from a couple of different perspectives. And we got some smaller contractors, and then of course you have a
Yep.
very large operation. How do you balance, God, family, career?
Mhm. I'll let you go first, Joe, on that one.
You should have been here to the first annual symposium.
Mm-hmm.
They had a whole is that live stream still? That was not recorded, probably. There
Or
was
no,
a
probably not.
work-life balance.
Yep.
That
we did it over there, right?
We
The
did
one
it in the
over-
gym?
over at the gym. Yeah.
Yeah.
With my dad.
and that was nice, but it's tough. Are you especially as a one-man show or a small company where everything kind of like the buck stops with you? Obviously, God comes first. We say that to practice it, takes effort, for sure. But your motto should definitely be like God, family, work. But in the summer, it can probably feel like that's upside down. I know a lot of HVAC guys, we can get our self-identity is so into our businesses, like growing it, and you've met people like that, I'm sure, where you can just tell like that is everything to them. Just try to recognize that, try to say at the end of my life, it is not going to matter how many HVAC technicians I had, how big my company was, how many installs none of that's going to matter. So just try to remember that, stay focused on really, honestly, what makes you happy. There's no, personally, I don't think that there's ever going to be a place where you're like completely content with the size of your business. If you want to grow it, you're always going to want to grow maybe a little more, because that's just, unfortunately, the human condition is that we're never satisfied. So I would just really try to be satisfied with wherever like me, speaking for myself, I am definitely happier in front of a piece of equipment than in an office, like managing people. So someone like that should probably not have great ideas to grow like a Kalos company, because it's not really going to make you that, any more fulfilled. So family, God, family, those are the things that will ultimately fulfill you, will be there in your time of need, not HVAC and not, customers and stuff like that. But yeah, we have times where it may feel like, families kind of taking a back seat in June, July, August, September. That's kind of, that's our industry, but at the same time, just kind of try to make that time up with them in the off season, playing some vacations, let them know, hey, we're working hard for this. We're going to take a nice vacation, Christmas, whatever, and stuff like that. So,
Yeah,
because you got to make hay when the sun shines.
Yeah. And also just all that stuff is a team effort when you have a family. So obviously intrinsic in saying that you are caring about your family means you have one, and having really good communication. And good communication does not mean it's conflict-free communication. I think a lot of people are looking for life to be easy and comfortable. That's not the life we chose. We're here to make other people comfortable, not us, right? And that means that, the people who are in your life, they have to be part of the reality, part of the conversation about that's true of almost any job. Like that, there's going to be busy seasons. There's going to be hard times. There's going to be stressful times. And making that, Leilani uses the terms holistic and sustainable a lot. Those are kind of buzzwords, but they actually do. That's a key to a lot of this, is that don't do something in part that's going to damage the whole, and also don't do things that cannot be sustained. And sometimes that, like, if you look at a summer, we're just like, man, I just worked 70 hours. That's not sustainable. But yeah, but if it's only for a couple months, then maybe that is sustainable. And that's where having that conversation with the people in your life and saying, hey, is this sustainable for us? Or are we just feeling a little upset and impatient right now, just because right now it's uncomfortable? I definitely do not encourage people to avoid discomfort, because that's not going to lead to growth. That's true of anything, right? You're adjusting your diet or exercising or growing a business or whatever you choose to do, sports, whatever. We don't want to teach our kids and the people in our lives that the goal here is just for everything to be perfectly smooth waters, because that's not realistic, right? And I think about that a lot with my kids, and my parents are very good at this. Having some struggle baked into the system, baked into that sustainable holistic system, is a really good thing. But that doesn't mean that I don't make myself emotionally available, that I'm so frustrated with work that I come home and kick the dog and throw the cat, like that kind of stuff. If I'm going to do that stuff, I do it for fun, not because I'm angry. That's a joke. I don't do that. Don't call PETA on me. No, like you have to function out of health, right? Mental health, spiritual health, emotional health. And if you're allowing your work or any choice that you make to make you unhealthy, that's a problem. But that would be like a lot of what I hear people saying is like, man, I can't work out because this is like really rough on me. It's like, yeah, when you're done working out, you feel sore, right? And that's the good kind, right? We're lifting a compressor with your back, not your legs. That's the bad kind, and that's true in a lot of different areas. That metaphor applies. So am I doing this hard thing because I'm growing and I'm building something, or am I doing this hard thing and it's hurting me and it's hurting people I love? And you have to be willing to do that. And like the women's panel that we just had was just one of the best panels I've ever heard. And the thing I took away from it more than anything else is just ask. Like, be persistent in asking and then listening. So if it's your wife or your husband or your kids, just talk to them about it. Hey, is this okay? This year at the symposium, this is a funny thing. Last year, my teenagers all pitched a fit about us affecting their lives and blah, 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 and their patterns and all this stuff. And we're terrible parents, and all we care about is ourselves and our friends. This year, we actually talked to them beforehand and said, hey, we care about all these people. This is something that it's hard for all of us to some degree. It's stretching. We're all tired. We're all cranky. You guys aren't going to get to hang out with your friends this week because you're helping out with the younger kids and all that. But can you like help us with this? Can you take this seriously with us? And man, their attitude totally changed. And I think and they've been amazing this whole time, really just great. And that's, I think, fundamental to a lot of these questions. Is like, it's not just us. It's not how can I do this? It's how can we do this? And if it's not healthy for then we need to make a change. But even then, it doesn't always need to be a wholesale change. Sometimes it's just a little tweak, just a little adjustment that can change everything. Maybe it's, hey, we're going to make time for a vacation. From my wife and I, it's every week we go on a date now. We used to not be able to do that, and now we can. And even there's that hour that we get away with each other makes a huge difference. And sometimes that's enough. You know, none of us are going to end up probably here. None of us are going to end up on a beach in Bali, just drinking margaritas all day. And who would want to anyway, right? That's not a worthwhile life. And from my perspective, I mean, some people would want to. I guess it kind of sounds nice, but maybe for a week, right? Maybe for a week. Yeah. It's the most common question that we get. And we're running out of time. I have to be at a panel in 9 minutes. So Eric, you have any thoughts on that? This is the stuff people like to hear about a lot. So it's where we ended up.
Yeah. I mean, it's one thing to add to that is when you're in those times when it is hard because the work is seeming to take the priority, it's really easy to forget the other times when you had time to do more meaningful stuff. So just try to remember when you're at those times that it's temporary, and make sure that they are like temporary. You don't want to be doing, like you said, 70 hours a week, 52 weeks a year,
right?
Working every day. That's no good. I mean, it's okay to do it every once in a while, but make sure that you take the time when you can to focus on what's important.
Yeah. Yeah. Corn didn't grow overnight. Yeah, that's good. It's important to, I don't know, anybody here ever get emotional? You ever get emotional, Joe? You don't seem very emotional.
Yeah.
Do you? Yeah. I get a couple people. I'm a very emotional person. And I wear my heart on my sleeve to an extent that my wife really wishes I probably didn't at times. And I understand that. But being able to, my dad and I talk about this a lot. My dad was an athlete in college. He's a very emotional driven person. And just realizing that all of this too shall pass, but just make sure it does, right? Like kind of like what Eric said. If it's something that where you're feeling strong emotions, then give yourself time to kind of get away to process it. People handle that stuff differently. For some people, it's going fishing or motocross. Not anymore, probably. No. But whatever it is, give yourself some time to do some of those things to allow yourself to get some perspective again. But I think a lot of people in the trades have kind of what I think you were saying, like identifying this is who I am. That's a slippery slope. You just have to be careful with that. Like it is a part of who you are.
And it can be a lonely place to be as a business owner. Too.
Yeah.
You're trying to keep everybody happy and everything running. And, you don't have that one person that you can just turn to and ask a lot of times.
Yeah, he was talking about the loneliness of being a business owner. Not everybody here obviously is business owners, a lot of techs, but it's lonely for techs too. It's lonely. It can be lonely for all of us. And that's where finding some community, reaching out, sometimes that can make all the difference. I have a group of people and it changes. It's not always the same people. Where you can just call me like, hey, I just need to talk to somebody, and being honest that that's what it is. And I've even learned that with people I'm close to. I'm like, hey, I'm just talking. This does not represent reality. Okay. I'm talking based on my emotions right now because I need to do that, but just realize I'm not going to go do anything crazy. Like I'm not going to go get, a ponytail and a tattoo and a mistress, like that's not going to happen. But right now I'm feeling kind of crazy. So just hang with me here, and learning how to do that with yourself too. And the people that you love is really big. Most people, if they love you, and trust me, people in your life, they do, even if they don't act that way all the time. They're going to really respect that if you can be a little more clear about where you're at. Recognizing that, it's sometimes it's just emotions. So anyway, that got deep. Anything you want to finish with, Joe?
No, that was much deeper than I
expected.
Could have gone.
It wasn't.
I'm kind of like, I do probably make decisions based on emotions more than I should, but like I try to keep those like bottled inside me.
Oh, that's
push
healthy.
down.
Yeah, just push them down. Just stomp those bad boys. Yeah,
but that's
Yeah, no, it's something that I've definitely grown in. You can call me about it, Joe. We'll talk. We'll talk.
I may have to.
Yeah.
Now.
No, it's good to see you guys. Love you guys. You guys are amazing, and it's good to get our once a year talk in. So I got to take off, but good stuff. Yeah, thank you all.
Thank you.